Good afternoon, class 10. So we are nearly at the third term examination of 2078 BS, right? Yes. And one thing I have to share. Earlier, they used to provide grade combinedly. I mean theory as well as practical. So combinedly, those who used to deserve more than 40%, the person used to get pass and get chance to study in higher education. But now they have slightly changed. You must get minimum 35% in theory and minimum 40% in practical to get chance in admission of higher education. That's why study is very important now. It has become a little bit tougher. You must deserve minimum 35% in theory. But you are the students of ANUPAM. 35% is very less. You must deserve 95%, okay? Yes. Understood or not? How much you have to deserve? 95. Okay. So, it's not impossible. It is possible. That's why impossible is made up of I am possible. Impossible makes you possible. And what are we doing? We are doing classroom presentation student wise. So 3 students they have already performed, right? 3 girls they have already performed. Sunaina Shrestha, Samiksha Dahal and Neha Saha. Now it's the turn of a boy to present his task. So it's already mentioned in the whiteboard. So slide is already ready. Force Kapil Lama, grade 10, SE batch 2078. Let's welcome him with a big round of applause. Kapil Lama.
Namaskar and good afternoon to our respected Vice Principal, all of my dear friends. As you all know, it's me Kapil Lama from grade 10, standing in front of you to give a presentation on the topic of force. First of all, I would like to thank our organizer who have organized this kind of program to increase the confidence level of the students. Now let's begin. Force is defined as the pull or push that change or tends to change the state of body, whether it is at rest or in uniform motion along the straight line. It is a vector quantity as it has both magnitude as well as direction. There are different kinds of force like gravitational force, magnetic force, frictional force, normal force, and many others. But we are in this presentation we are going to discuss about gravitation. What is gravitation? Let's start. The mutual force of attraction between 2 bodies is known as gravitation. Every body in this world possesses gravitation. Now let's discuss about Newton's law of gravitation. What is Newton's law of gravitation? Newton's law of gravitation states that every object attracts every other object in the universe with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. It means that the product of the masses of the 2 bodies is directly proportional to the force of attraction between them and inversely proportional to the distance between their centers. Why is Newton's law called universal law of gravitation? Because it no matter how small or big the object, the law is applied in everything. A verification of Newton's law of gravitation. As we know from the law, that force is directly proportional to the product of their masses and inversely proportional to the distance between their centers. When we combine this equation, we get force inverse force force m1 m2 and divided by d square. The proportional can be changed into F is equals to G m1 m2 divided by d2, because G is gravity a constant and it doesn't change. This a universal gravitational constant, as we discussed already that it is a constant in the whole universe, and its value doesn't change at all, and it is a scalar quantity, and its value is 6.667 into 10 to the power minus 11 nm square and per kg square. It was first discovered by Henry Cavendish. Relation of gravitation with its factors. Let's discuss about it. When the masses of bodies change, keeping the distance between them same or constant, let's discuss about it. First, if the mass of one body is doubled by keeping the distance constant, let's begin. As we all know, F is equals to G m1 m2 by d square. If the mass of one of the body is doubled by keeping the distance constant, it means making one of the masses of the body double and keeping the distance constant. It means the gravitational force will be 2 times the previous. Hence the force of the gravitation between two bodies is doubled if the mass of the one body is doubled. Another one. Now second case, if the mass of the both bodies is increased by 2 times, it's by keeping the distance between their center constant. Let's begin. It simply means it simply means that sorry for the interruption. Let's continue. There's the another condition. When if the masses of both of the bodies is increased by 2 times each by keeping the distance between their centers constant, what will happen? As we all know, force is G into F is equals to G into m1 m2 by d square. When the masses of both bodies increased is doubled, it will be G into 2 m1 into 2 m2 by d square is equals to 4 G m1 m2 by d square. In this condition, when the masses of both of the bodies is increased by 2 times each by keeping the distance between their center constant, the force of gravitation will be 4 times the previous. Let's go to the another conditions. When the masses of the body is constant, but the distance between their centers are changed, what will happen? Let's see. Discuss this. In the first condition, let's see. If the distance between the two bodies A and B from their centers is halved, keeping their masses constant, it means F is equals to G into m1 into m2 by d by 2 whole square is equals to G into m1 into m2 by d square by 4. It means the force of gravitation will be 4 times the previous one. Next one. In the case when the distance is doubled, the force of gravitation, as we can see when when the distance between two bodies of their centers is increased by 2 times, the force of gravitation will be 4 if the distance between the two bodies from their centers is increased by 2 times by keeping the masses of the bodies constant, according to the statement, the force will be 4 times less than before. Now let's go to numericals. Two bodies. Numericals. Let's go. Two bodies with the mass of 200 kg each are kept 2 meters apart from their centers on the surface of the earth. Calculate the force of attraction produced between them. It is a simple numerical which can be solved with the formula obtained from earlier. In given, as we know, there are two bodies, means m1 is equals to 200 kg and m2 also 200 kg, and distance between them is 2 meter. Then F is equals to g into m1 into m2 by d square. G means 6 into 6, 67 into 10 to the power minus 11 into 200 into 200 by 4. Then the force of gravitation will be 16.67 into 10 to the power minus 7. Let's continue with the numericals. The second numerical question is, what will be the force of attraction if the distance between these two bodies is half to, in the example 1 above. It means that if their distance is half, means it's simple, it will be 1 meter, distance will be 1 meter. In that situation, the force of gravitation will be 6.67 into 10 to the power minus 11. It will be 2.668 into 10 to the power minus 11. Now I would like to welcome Lokendra to do the example number 3. Why not? Yes. Three into 200, 600 kg. माथि भन्नु 2 meter. छोड़ दे Thank you, Lokendra. Let's continue our presentation. Special features of gravitational force. What does the gravitational force? What are the special features of gravitational force? Let's continue. The gravitational force between light's body is extremely small. Hence, such smaller force is not felt in practice. However, it becomes noticeable in the case of massive bodies like sun, moon, earth, and other heavenly bodies. Another special feature of the gravitational force: the distance between the sun and the earth is about 1.5 into 10 to the power 7 kilometer, and the gravitational force between them is 10 to the power 27 Newton, which cannot be ignored. Thus, the earth revolves around the sun due to the gravitational force of such large magnitude. Due to the gravitational force of sun, all the heavenly bodies in the solar system revolve around it. Now let's talk about gravity. What is gravity? Gravity is just merely a special special case of gravitation in which heavenly body is involved. In other words, it can also be defined as the force of gravity in which the earth pulls a body towards its center. The factors affecting the gravity are masses and the radius of the planet and its satellites. Effects of gravity. We are able to stand and run, perform other activities freely due to the gravity of the earth. If there was no gravity, we would have been levitating. Construction of building and bridges is also possible due to the gravity of the earth. If a body is thrown upwards, the motion is opposite to the gravity of earth, so it comes back to earth. It is due to gravity that even if we throw anything, any object in air, it will come back to the earth. Acceleration due to gravity. What is acceleration due to gravity? Let's discuss. Acceleration due to gravity is defined as the acceleration produced in a freely falling body due to the force of gravity of the earth. It is denoted by g, and its SI unit is meter per second square, and its average value is 9.8 meter per second square. Next, acceleration due to gravity on earth. The acceleration due to gravity on the earth is smaller due to the less mass of the moon, and its acceleration, the value of acceleration due to gravity on the moon is 1.67 meter per second square. Falling bodies and acceleration. Feather and coin experiment. Let's discuss about the feather and coin experiment. It was put together by Sir Isaac Newton. Sir Isaac Newton put a coin and feather into a closed, long and wide tube. When the tube was inverted, it was observed that the coin fell much more quickly than the feather. The tube was evacuated using a vacuum tube. This time it was observed that both coin and feather fell together, reaching the bottom of the tube system. It shows that they fall at the same. It shows that they fall at the same rate in the absence of air resistance. This experiment confirms that acceleration due to gravity is of freely falling body, whatever their masses, is the same if there is no air resistance. Difference between acceleration due to gravity and universal gravitational constant. It is g, or simply acceleration due to gravity. It is the acceleration produced on the body due to the gravity of the earth or heavenly bodies. What is gravitational constant? The gravitational constant is the gravitational force between two unit masses separated by unit distance between their centers. The SI unit of gravity is meter per second square, whereas the SI unit of g is Newton meter square per kg square. As acceleration due to gravity has both magnitude and magnitude and direction, it is a vector quantity, whereas gravitational constant is a scalar quantity. Thank you. Let's continue. The relation between acceleration due to gravity with the Earth's radius. As we all know, the force of gravitational is equals to g into m by r square. The force with which the body is attracted by the Earth towards its center is given by F is equals to mg. Mass and acceleration due to multiplied by acceleration due to gravity. From this equation, we can see that mg is equals to gm into m by r square, and the masses are deducted, and we are remained with g is equals to g into m by r square, as g as gravitational constant and mass is constant. In this condition, g is equals to g is directly inversely proportional to the radius square of the radius of the heavenly body. Let's discuss about mass. What is mass? The amount of matter contained in the body is known as mass. It remains constant everywhere, and it is an scalar quantity, and it is measured by physical balance or beam balance. Let's discuss about weight. What is weight? Weight is weight of a body is defined as the force with which it attracts towards the center of the planet. It is measured by spring balance, and its SI unit is Newton. Difference between mass and weight. Mass, it is the amount of matter or content in a body, whereas weight is the force in which a body is attracted towards the center of the planet or satellite. Mass, as it is constant everywhere, it is a scalar quantity, whereas weight, as it has both magnitude and direction, it is a vector quantity. Mass, its SI unit is kilogram, whereas the SI unit of weight is Newton. Free fall. When a body is falling freely towards the center of the earth under the influence of gravitational pull of the earth, the motion of the body is called free fall. Free fall is the type of motion of a body in which is moving under the influence of the gravity. In this condition, the body is in weightlessness, and it becomes this is because the body feels zero reaction force. Weightlessness. Weightlessness is a special condition of a body in which its weight seems to be zero. When a body is falling freely under the influence of the force of gravity, or when the acceleration of falling body is equal to the acceleration due to gravity, it experiences weightlessness. When a body is at the Earth's centers or in the space at null, it also experiences weightlessness. And at last, when the body of the artificial satellite becomes weightlessness, when the artificial satellite is orbiting around the heavenly body, because its centrifugal and centripetal force are equal and opposite. Thank you.
Okay. Thank you very much, Kapil. So, Kapil has performed today. Now today also there must be evaluation, right? Yes, sir. So from where should we begin the evaluation work? From where? Okay. Who wants to evaluate? Please raise your hand. Manish wants to evaluate. Okay, one Manish. Next one Samiksha. Another Arju. Where is Arju? Okay. Arun. 4. Pooja and Sutishna. All together I have chosen 6 students. Okay. So let me call them. So now you can evaluate his presentation. Come on.
Okay. Lama, give a presentation. It was fabulous and great presentation by Kapil Lama.
Oh, that much. Okay. Arju, please evaluate.
My friend Kapil, Lama, done a great job. I appreciate your performance. You explain us numericals really nicely. It makes our doubt clear. Thank you.
Thank you very much. Turn off Arun Gurung. Please, Arun Gurung, you evaluate his
My
performance.
friend Kapil, done.
Great job.
My friend Kapil explained. My friend Kapil explained. My friend Kapil explained very nice.
Very nicely.
Very nice and I like it. Thank you.
Now it's the turn of Samiksha.
Shall I start or what? Kapil did very good presentation. He explained us about force which made our doubt clear. Although he left some portion because of time management, but also he did his best to explain us about the topic.
Thank you, Samiksha. Now it's the turn of Pooja Sharma.
I just want to say that Kapil, you did a great job, and your performance was fabulous. And I really like the way you presented the topic. The topic was more enhanced efficiently, and if you have managed time for all those portions, then you could have made us clear more about the equations and numericals. And that was all.
Thank you, Pooja. Now it's the turn. Sudishna, how do you judge?
First of all, I like to thank Kapil for explaining this chapter more clearly. Talking about his presentation, he used a black background, which was more effective. Thank you.
Thank you. Okay. Now finally here we have got Lokendra, because Lokendra was called in that stage and asked to do the numericals. Okay, Lokendra, how do you judge your friend's presentation?
My friend Kapil Lama did very well, and from my opinion, from all presentators, he is the best presenter in this year. Thank you.
Thank you. Thank you very much, Kapil. So, presentation is a challenge, isn't it? Last time also I told, when you are there, you feel more confident, then you have got lots of ideas. And when you come in this place, then 99% idea goes somewhere else. And 1% idea is left. And from 1% idea, you have to increase and make it 99%, isn't it? Okay. So, if you become too much hurried, then it will be quite difficult. So, in comparison to previous presentation, now our presentations are being more systematic one and effective, right? But I want to suggest you what to do. The slide will be just displayed in that side. According to that slide, if you write and explain, it will be easy. Understood or not? Right? So who knows? Later on, you will be a great motivator like that Sandeep Maheshwari. Have you heard name or not?
Yes.
So once Sandeep Maheshwari was also similar type person, very shy nature. But now he has got many followers,
Yes, sir.
and he is one of the best earning motivator of India.
Yes.
Understood or not? By speaking also people they can earn money. Motivation is a great trick. Understood? So you have to keep on doing your job. And next day's presentation. Presentator is Pooja Sharma. Pooja, just be ready and make your presentation a little bit different than your friends. Okay, thank you. Have a great time.